I'm not going to turn the camera. We have 30 people all in San Diego. I'm in Haddie, San Diego. And I'm going to give you the sharing. First, maybe talk a little bit about background of your college life because we have kids here and students in Brown, of course, similar age, a little bit younger. Just like maybe three advice to high school students, college students is in this rapid AI changing field. That's one thing. And then show your discrete math and why the discrete math is a core course for engineering and computer science. Okay. Mhm.
Okay.
Yeah. You want to give a few advice? I'm sorry, I pull you on the, I don't know.
Oh, sure. Advice for what specifically?
Yeah, it doesn't matter. Just like if they are in high school in CCA, what they need to pay attention to, or how they take advantage of college resources. Maybe one sentence for high school students, one advice for college students. Okay. Mhm.
Okay. Um, let's see, high school students. I would say one, t take the hardest classes your school offers. It's just a general advice for being prepared for applying to college and taking hard college classes, just because those classes are going to massively put you at an advantage when you're taking college classes. So a lot of students from CCA or other competitive San Diego high schools have found Berkeley to be easier than a lot of the other students that didn't take these really hard AP classes. So that's my first advice to high school students. My second advice to high school students is try to find something you like doing outside of school, just as a hobby. I think it's very important because in college you won't have as much time for hobbies or anything, but finding something that you can do now, just at least maybe once a week or regularly is good, just to form a habit, and you'll have something to entertain yourself throughout your life. Um, College students, I would say there's like two things. One, if you're a STEM major, you should learn how to use AI correctly. There's like two ways to use AI. One is using it and it, just does everything for you. And two is, using it sparingly, but, for, important things that I'll explain in a second. So I personally am thankful I grew up in an era without AI because I think if I had access to AI, especially during high school and early college, I wouldn't have learned anything. Um, you know, once you get used to using AI, you get very mentally lazy, as you don't want to solve it yourself anymore, and you just ask AI to do it, especially with things, at the college level. These are, pretty well documented things that AI has access to and has been trained on. So any, class that will see in college, you can just ask AI to do the assignment for you and it will, and it can. Um, However, AI is good for some things like it's essentially can be used as a very useful search because you can, give it more detailed descriptions of things. It's also really great at being used as a summarizer or describing a certain field or some kind of concept generally. So I would say use AI for until you've mastered the specific skill that you're trying to learn. So, you know, you might say, oh, but all the software engineers right now are using AI. But keep in mind that software engineers that are currently graduated and working have already learned to code and already learned how to work with complicated software before AI came. So you should think of it like this. In elementary school and middle school, we're forced to do like multiplication with by hand and do math by hand. But maybe in high school they give us access to a calculator. But even if even though the calculator existed, it didn't mean that the multiplication by hand was useless. It sort of forced you to understand how to do things before you're given the tool that just does it for you. Because eventually, if you just rely on it, it's gonna get, sophisticated enough to the point where you don't know how to fix something if it goes wrong. So, just be careful about using it too much because if you do rely on it, you will learn nothing, and that's like not great. Um, as for internships and stuff, I don't know, just apply, but I'll take any more specific questions later. But I'd say those are my main advices.
Yeah, very good, very good. I like the analogy with the calculator. I have you to, could you want to share something about discrete math or you just want to
Oh,
talk about it? Mhm.
let me see if I have my syllabus. Hold on.
Okay, yeah.
Uh,
So discrete math, again, was a TA for Berkeley, CS 70. It's a qualifier for going to become a CS major and DS major. So you can go study, get into ladder science, can study anything, but you have to pass. That's the most difficult class to pass. And why we had students, the eighth grader or seventh grader and the college sophomore together taking discrete math from him. And people were like shocked. Oh my gosh, how can a college kid and the seventh grader take together? They can because this is not taught by Common Core. It's nothing overlapping. It's very interesting. And it's a key thing going to computer science, EE, physics. So if you guys are interested in math, we have Google review. We can show you that it's a student share. So go ahead.
okay, so this is a syllabus. It can be subject to change, but generally the overview and learning objectives should be the same. So yeah, as Danan said, discrete math is the essential class for all computer science majors, all electrical engineering computer science majors, as well as all mathematics majors, and even physics majors can benefit from discrete math. Um, I would say this is a class that's very different than anything that most middle school and high school students have seen, since it focuses a lot more on, logical structures and not necessarily like algebra. So the typical middle school and high school curriculum focuses on algebra and calculus. But here we're primarily focused on problem solving without, relying on just techniques that have been developed, but we will, develop sort of techniques from scratch. So in calculus, you're given integrals and you're given five options of what type of integral it is, and then your job is just to assess which type of integral it is and apply the technique and make sure your algebra is clean and do not mess up. But here, it's a bit more complicated since we have to sort of think harder rather than be given a cookie cutter problem. So I'll give you a problem or I'll give a student a problem and it may be nothing like they've seen before. However, they should be able to break it down into more simple concepts and solve the problem with creativity and problem solving skills. So a question like this might be, I have some sort of grid and I want to ask the student how many ways are there to travel the grid, you know, when I can only move right and up. And they'll have to sort of think of some sort of idea about how I can count the number of possibilities and then give a, semi-rigorous proof of why their answer is correct. However, for this class, I've adapted it to be more suitable for middle school and high school students. So the two main things we'll focus on in this class are mathematical logic and counting. So here it says counting, graph theory, number theory, logic, but primarily be talking about logic and counting, and the other two are more special topics that we'll just give a brief overview at the end. This is going to be adjusted because I recently taught the class and I had to, adjust pacing in order to make it more digestible. So logic is something that's really important within math and computer science, as it is the foundation of, well, all the computers are based on Boolean logic, and it gives a way to axiomatize any sort of informal statement into a statement that can be discussed formally with proof. So, For example, we may take some sort of English statement like, if I am a cat, then I am a mammal, and sort of understand how to turn it into a logical structure. And from here, we can break down even more complicated sentences and understand implications of where this comes from. Learning basics of logic are, a very core necessity to doing anything mathematically related or computer science related.
Okay.
Um,
I think I need to stop you here. So we're
sure,
running out of time. Yeah. Do you guys have any questions for him? Yeah, go ahead, Danny.
Yeah, can you just scroll down a bit so I can see what the prerequisites are?
sure.
It's you take a class, or you take a test.
Okay.
We'll send you a test.
Yeah,
Yeah, I
the
think
test.
it's interesting
Yeah.
for you. Yeah, go ahead. Yeah. But the prerequisite is a test, and you pass the 80%, we'll take it. Yeah, you'll enjoy it. We have to do students at college, physics are taking it. They're really enjoying it. Yeah. Any other questions? Yeah. Discrete math. Yeah. No. That is Liam, discrete math semester Olympiad?
It has overlap, yeah.
Because I saw the counting and the number series part of Greg is like the competition as well. So don't know how much overlap he has. Like for those.
Liam, how much overlapping with the competition math?
Um, Probably the counting is overlap, but logic not overlap. There's more focus on proof here.
More focus on proof here.
Proof.
Yeah. Okay, very good. Any other questions?
When does the class?
Starting I think the 18th or 17th next in 1 week or 2 week. Yeah. We'll send you the link. The kids need to pass the test. Okay, that's important. I mean, you will. All of you will pass the test. I'm very confident. We just want to have a little bit of knowledge. Like a Python, if you go to Miss Maro's AI for the Python, it's not hard. If you know Python, you can pass it. But don't think the program is easy. That's the way we get the students, but they will be challenged. Okay, the class will be challenged. Okay. Any other questions? Okay. No. Okay, we'll let you go.
Okay.
Yeah. Thank you for your time. Okay, you can
Yeah.
continue. Thank
Okay.
you. Okay, bye.